In the last video, I have explained you what is Ohm's law. Now we will check whether Ohm's law can be proven or not. What is Ohm's law? Ohm's law is nothing but V is directly proportional to I. Now this means that V is equal to a constant. What is the constant here? R into I. Now V by I is equal to a constant, that is R. So this is what the mathematical representation of Ohm's law. If we are able to prove this equation to be right, then we are basically proving that Ohm's law is right. Now we will check with our known equation, the learned equations with V and I, whether we are able to get a relation, that is V by I is a constant. Now V is equal to, we have learned an equation in chapter 2. What is V? That is electric field into length. And what is the value of current we have learned? We have learned the value of current as NAEVD, where N is number density, A is area, E is charge of an electron, and VD is drift velocity. Now using these two equations, and one more equation we have learned, drift velocity is equal to minus E tau divided by m, where E is charge of an electron, E capital A is electric field, tau is relaxation time, and m is mass of an electron. Okay. Now we will substitute the value of drift velocity in this equation. Now we will get a new value for current, and that we will substitute here. So first we will start from V. What is V? V is equal to electric field into length. So we know there is a negative sign here, right? V is equal to what equation we have learned? dV is equal to E into dr. So there was a negative sign. You can go and check chapter 2 when we have derived this relation. So there is a negative sign, so we will substitute the value with sign, minus E into L divided by, what is the value of current? NAE, and for drift velocity I will substitute minus E tau by m. So this is multiplication. This negative and this negative can be cancelled, and I can rearrange this equation as, I can also cancel E electric field and rearrange this equation. M into L divided by N into E square, E into E square, tau, N into E square into tau, and we will have A outside. We will check the equation once again. M into L divided by N into E square, tau, and A. So this is the value of V. Now see, for a conductor, check whether these values are constant or not. M is nothing but mass of an electron, that is anyway constant, 9.1 into 10 power minus 31 kilogram. L is length of the conductor, that is a constant for a conductor. Now N is number density of a conductor, that is for a specimen, that is constant. E is charge of an electron, that is constant. Tau relaxation time at a constant temperature and pressure, relaxation time is constant. A area of cross section of a conductor for a conductor, that is constant. Now we have proved that V by I is equal to constant, that is the value of resistance. Now we will also get an important relation. What is that? We also have learned R is equal to rho L by A. Now compare these two equations. V by I is nothing but resistance, right? Resistance. Now we have an equation M divided by NE square tau into L by A. See, what is the coefficient of L by A here? Rho. Now what is the coefficient of L by here? M by NE square tau. Now equate these two values, that is, this resistance is equal to this one. So I am equating this value with this value. What is that? ME into L divided by NE square tau into A is equal to rho L by A. L will cancel, A will cancel. See, we got the value of rho. What is rho? Resistivity. What is the value? ME is nothing but M apostrophe E. Okay, M is nothing but mass of an electron, and N E square tau. ME divided by NE square tau is the value of resistivity. Clear? Now in the next lesson we will see how does the value of resistivity varies with temperature. So basically variation of temperature with resistance for different types of material like alloys, then electrolytes, conductors and semiconductors we will see in next lesson. Thank you.